So a lot of you are probably wondering how the orbitals kind of interact with each other and around the nucleus and so forth. So this little video is just kind of going to show you that. What I have here are overhead slides. So this is really an old method, but I couldn't find anything animated online that I liked and was simple enough. So we're going to go with the old-fashioned stuff. So here I have what represents the 1s orbital. Notice in the center, that little black dot represents the nucleus. So the orange represents the electron density. Where are you likely to find the atom? And so what you're seeing is that the density is closest to the nucleus, and as you move away from the nucleus, the color dissipates because the electron density dissipates. It's less likely to be found the further away from the nucleus you go. Now this is the 1s, so it's relatively small. I'm going to overlay the 2s now. Hopefully you can see the yellow. Oh yeah, that shows up really well. So here's the 2s. And notice that it's still spherical, but now its electron density extends much further away from the nucleus. Because it's got more energy, it's further away from the nucleus. So now we're going to put in the p's. So remember that the p's are two-lobed. There are 3 of them. They are oriented along the x, the y, and the z axes. So here's the 2-lobed, so I'm still marking the nucleus, which is immensely huge at this point. Here's the x overlapping the 2x overlapping the 2s. Okay, that's the first p orbital. Notice that they're still kind of occupying a lot of the same space. Yes, the p orbital extends a little bit beyond the s, but they also overlap a whole lot. I'm going to put the x on here, or the y on here now. And then we'll add the z, and you can kind of see that the 3 p orbitals make up the sphere that the s also occupies. So you've got this 3-dimensional idea going on. So within one of these orbitals, so for example within the blue orbitals, there are 2 electrons, or have the potential for 2 electrons. Or do they have to be on opposite lobes? Absolutely not. They could be in the same lobe, because remember, they have to spin in opposite directions, so that allows them to get relatively close. Their motion is completely unpredictable. We don't know. We know kind of where they're located. We know kind of what their motion is, but you can never pin those 2 ideas down. So we're just showing you the electron density. Most of the time, this is where you're going to find the electron. And so a really good analogy for this is the firefly analogy that I shared with you a little bit earlier. If each of those dots represents where you see the firefly flash around the pheromones, this is the visual of what you would see if you had a time lapse and could add it all together. So I'm not going to do any D's or F's. They get a little complicated. There is a video later on that I'm going to share with you that does have some D's in there, but it keeps it rather simple. It doesn't have all this overlap going on. All right, so we're going to move on and take a look at the 3rd principal energy level now.